Hello my dear students, good morning. Now we will discuss about chemical equilibrium. Previously we discussed about that particular mole concept. Now we will discuss about the chemical equilibrium, which is very important, and chemical equilibrium and ionic equilibrium. So you have two chapters. So from two chapters definitely you will have 2 to 3 questions. Okay. So mainly in physical thermodynamics, equilibrium, electrochemistry, and mainly these three, and solid state and solutions. Okay. And solid state and solutions, maybe one question will come, but from here you will have 3 questions, and even from electrochemistry you can have 1 or 2 questions, and one more thing, that chemical kinetics, those all are important, and from this chapter you can answer very easily actually. So let's see what you will have without wasting time. So if you see here, what is equilibrium? So equilibrium means, everybody knows, it is a state or position at which the rate of forward reaction is equals to rate of backward reaction. So I repeat, equilibrium means the state or position at which the rate of forward reaction is equals to rate of backward reaction. What is rate of reaction? Rate of reaction means change in concentration of either reactants or products per particular time, in a unit time we will call. Okay, I repeat, rate of reaction means change in concentration to the time, unit time. Okay, so whose concentration will change? Who are reacting? Those concentration will change from certain concentration to another concentration. Okay, so that is actually equilibrium. So equilibrium, to understand, we will have two, that is, one is a forward reaction and one is backward reaction. What is a forward reaction and what is backward reaction? Very, very important. Forward reaction means only reactants converts to products. Reactants converts to products is a forward reaction. So backward reaction means, everybody knows, backward reaction means, okay, so here products, ulta reaction. So products converts to reactants. This is backward reaction. Okay, so next most important thing is equilibrium reaction. Equilibrium reaction, how we represent this same first one, we will write like this: reactants converts to products. But this is what forward actually. If you write full arrow like this, okay, but if you write half arrow, this is forward reaction. If reverse, if you written half arrow, that is backward reaction. So this is equilibrium reaction. Okay, next is, this is equilibrium symbol. What we call this? Reactants, equilibrium, products. Okay, this is the symbol of equilibrium. That's it. Okay, so when equilibrium exists, the rate of forward reaction is equals to rate of backward reaction. Then equilibrium exists. Correct? So what I am saying here, at equilibrium, rate of forward reaction is equals to rate of backward reaction. What is forward reaction? I told you. R means what? Small r, rate. Rate of reaction. Rate is nothing but speed. What is the speed of reaction? How we calculate? Just change in concentration by time taken. That is rate. So rate, everybody knows, in chemical kinetics also you have in second year. So rate means simply it's a change in concentration by time taken. Time taken. This you can write. Whose concentration? This is a concentration of either reactants or else products. This is what rate of reaction. So very much important thing for you. Okay, next, the most important thing is, what is law of mass action? What is law of mass action? So this given by Goldberg. So rate of reaction according to this law of mass action, rate of reaction is directly proportional. Rate of reaction means what? R. Okay. So rate, simply rate of reaction, small r, is proportional to product concentrations of reactants. So this is rate law. Even in chemical kinetics you have. So rate is equals to R is equals to, you can take proportionality constant K into concentration of reactants. Concentration of reactants. See, for a reaction, suppose AA plus BB equilibrium CC plus DD. What these are? Small c and small d, number of moles, reaction coefficients. Otherwise, small c and small d are reaction coefficients. Even here, small a and small b are also reaction coefficients, or number of moles of A and number of moles of B. B and A are reactants. Capital A and B are reactants. Small a and small b are number of moles. Then for this, if I want only forward reaction, what is the rate of forward reaction? RF is equals to KF into concentration of A. These moles also important because those moles also influence the rate. So KF into concentration of A power A and concentration of B power B. So into product means into. So here what is K? K is rate constant. Here what is KF? KF is rate constant of forward reaction. Rate constant of what? Forward reaction. Very, very important. What is KF? KF is rate constant of forward reaction. Very, very important. Write down law of mass action. According to law of mass action, the rate of any reaction. If forward reaction, we will take reactant concentrations. If we take rate of backward reaction, then you will take product concentrations here. Then it will be rate of backward reaction. That's it. Okay. So what according to this law of mass action? For any reaction, the rate of reaction is directly proportional to product concentrations of reactants. That is exactly rate law. Simply what? Rate law. Or else this is the rate equation. What we call the rate equation. See. Okay, sir? So very, very important. Please note it down. Okay. So next, the most important thing is directly we will enter into what? Concentration equilibrium constant. Kc and Kp. Those we will discuss now. Okay, sir? So the most important thing is here we will discuss, that is rate. Oh, sorry. Rate already we discussed. What is that? Kc. Everybody knows. What is Kc? Kc means concentration equilibrium constant. This is called Kc. Concentration equilibrium constant. For a reaction AA plus BB equilibrium CC plus DD. For this equilibrium reaction, as I told you in previous, what we write? Kc means directly I write here. Kc is equals to Kf by Kb. Kf by Kb, important. Okay. So this comes from in previous law of mass action. So if you have any doubts, you can check first year notes. So Kc is equals to Kf by Kb is equals to product concentrations, means concentration of C power C, concentration of D power D by concentration of A power A and concentration of B power B. This is what we call Kc. What is this? Kc. Simply you can write Kc is nothing but inverse you can write. Who is capital C and capital D? They are products. Okay. So what this square bracket Square bracket indicates concentration. Whose concentration? Product concentration. Which product? The product C, capital C. What is small c? Number of moles of C. Small c here, like this. Okay, product concentrations of products here. Okay, this ratio. Kc is the ratio of product concentrations of gaseous products. Product concentrations of gaseous products to the product concentrations of gaseous reactants. Very, very important. This is what inverse Kc. Inverse Kc. See here in Kc while writing, we won't consider any solid reactants and solid products. If any solids are there as reactants and products, we won't consider their concentrations in Kc, because those concentrations we will take as unity, because solids are highly rigid, so they cannot take part in chemical reaction. That's why we won't consider. So simply we will write Kc is product concentrations of gaseous products to the product concentrations of gaseous reactants, like this. For, I repeat, for solids we won't consider particular what? Concentrations. For gaseous, we won't consider concentrations for solids. Okay, even for liquids also we won't consider sometimes. When we won't consider for liquids, liquid if is in excess, that concentration we won't consider. But liquid concentrations we will consider when all reactants and products are liquids. Then in Kc, those concentrations of all product liquids and reactant liquids we will consider. So I told you here 3 points. What is that first point? For solids, concentrations should be unity. Unity means what? 1. For solids, concentration should be unity in Kc. Okay. Next, second one is for liquids which is in excess. Liquid which is in excess, then concentration should be unity in Kc. So for all gaseous reactants and gaseous products only we will take in Kc. If any solid is there as a reactant or in product, those concentrations we will take as unity. Number of moles? 0. How many moles? They cannot affect the rate of reaction because solids are highly rigid. So their rate of reaction won't affect. Understanding everyone? So this is about particular. And third, last and final. If all reactants and products are liquids. If all reactants and products are liquids, then concentrations of all we will consider. So this is very, very important. These are all 3 points. Please note it. Okay, so this is about Kc. And one more thing I forgot to tell you. Kc units simply concentrations power delta n. Concentration power delta n, that is Kc units. Units of Mr. Kc. Concentration power delta n. What is delta n here? Change in number of moles. Change in number of moles, that is C plus D minus of A plus B. So these are products moles, right? Small c and small d are products moles, right? Small a and small b are reactant moles, right? Then what you can write? Delta n is simply change in number of moles. So this is about Mr. Casey. Okay, so in Casey, when we will consider concentrations, I told you very clearly in these points. For all gases only we will consider generally, all reactants and products concentrations we will write in Casey. If solids, pakka, blindly, their concentrations we have to consider unity. Means we will neglect that completely. That's 1 mole, 2 mole, 10 moles, not matter. Got it? So that's it. And about liquids also I given. So very clearly. So please note it down. And next we will enter into next without wasting time. That is, you know what? Kp. Kp, partial pressure equilibrium constant. What was that? Partial pressure equilibrium constant. So simply Kp we write. What is Kp? Kp is a partial pressure equilibrium constant. Simply we write for the same reaction AA plus BB equilibrium, writing always capital C. Cc plus Dd. In this reaction, what we write Kp means partial pressures of C power C, partial pressure of D power D, partial pressure of A power A, and partial pressure of B power B. So this is what we call Kp. Partial pressure of A, partial pressure of B, partial pressure of C, partial pressure of D. Sometimes they won't give. Even we can calculate what these are. Partial pressures of A, B, C, D respectively. What are AB? Capital A, capital A, B are reactants, capital C, capital D are products. I won't waste time. So directly I will go for it. So Kp you have. Now how to have sometimes partial pressures like this? Partial pressure is equals to mole fraction of A into P total. So here, what is Pa? You have idea already. So what is the mole fraction of A? Number of moles of A by total moles means number of moles of A plus, number of moles of B plus, number of moles of C plus, number of moles of D. Total moles of all reactants and products you have to take. This you know already. What is mole fraction? It is the ratio of number of moles of one component to the total number of moles of all components. So in concentration terms, you know all these things. Correct? So what is PT? PT is the total pressure. What is this? Total pressure. Total pressure, P total. What is Xi A? It is the number of moles of one component to the total number of moles of all components. Got it? Here I won't repeat what is capital A, capital B, capital C, capital D. That's it. Simply, why you are giving like a mad fellow? You are thinking sometimes they'll ask Kp without directly giving Pc, Pd, Pa, Pd. Then they may give total pressure and of course how many moles are present at equilibrium you can have at equilibrium. So in that way you can have this. So mole fraction of A you can have from the number of moles. What these are? Mole fraction at where? At equilibrium. Because this Kp means at where? At equilibrium. That's what. So and what is Pb? So mole fraction of B into P total. Okay, so these are all partial pressures at equilibrium. So these are all partial pressures at equilibrium. Similar way, Pc mole fraction of C into P total. Pd mole fraction of D into P total. Like this you can write. Hope you understood. Okay. So again, units. Units of Mr. Kp is atmosphere power delta N. Because pressures units is atmospheres, no? Same story, delta N will be C plus D minus of A plus B. They should be gaseous. Otherwise, those number of moles you have to take as unity for solids. Remember this one. Got it everyone? Even liquid is in excess, you have no need to consider. If all reactants and products are liquids, then those number of moles you have to consider. Number of moles for solids you have to take as unity. Don't worry and don't get confused. For, as I said, for solids, concentrations you have to consider unity. Same for solids, number of moles should be 0. Suppose like this, H2 plus I2 equilibrium 2HI, then delta N will become 2 moles of products 1 and 1, 2 moles of reactants 0. So for this reaction, Kp units means no units. No units for Kp. Why? Because number of moles becomes 0. Even Kc units. If number of moles change, if 0, if delta M is 0, then no units. Remember this one. They'll ask you which of the following have no units for Kp, like that. They'll ask you. Okay? So the last question, like which of the following will not have any units, like that. They'll ask you question. So important for you. So this is about what? Kp. Okay? And how to have a Kp. And I given units for Kc and Kp. Now you have this relation between Kp and Kc. Relation between Kp and Kc. Simple, I'll give you Kp is equals to Kc into RT power delta M. Everybody knows. I won't repeat this. This of course you have a derivation for this, but now simply you can write Kp is equals to Kc into RT power delta N. Okay, so from ideal gas equation, from this P is equals to concentration CRT, ideal gas equation, Pv is equals to nRT, from that P is equals to C into RT, like that Pa is equals to concentration of A into RT, like that you can write what? Pb is equals to concentration of B into RT, like that you can write Pc is equals to concentration of C into RT, Pd is equals to concentration of D into RT. If all Pa, Pb, Pc, Pd, if you substitute in Kp, you will get this relation. Because here you have concentrations, right? You can substitute or not in Kp. So you will have that. Okay, this is not required actually. So simply you take this relation. Kp is equals to Kc into RT power delta N. So as I told you, if delta N is 0, then Kp is equal to Kc. If delta N is greater than, that means positive, greater than 0. Delta N, how you will calculate, everybody knows. C plus D minus A plus B. Number of moles of products minus number of moles of reactants. So if positive, then Kp is greater than Kc. If it is positive, something you are multiplying to Kc, then it is equal to Kp. Means Kp big, Kc small. If delta N is negative, negative means what is the meaning? Delta N is less than 0. Then what you will get, and Kp is less than Kc, like this. So this is a relation between Kp and Kc. Alright. So this is one of the most important thing, relation between Kp and Kc. And from this, they can ask one question. Which of the following, in which of the following Kp is greater than Kc? In which of the following Kp is equal to Kc? In which of the following Kp is less than Kc? Which big, which small, which equal, they can ask you. So that simply you have to calculate delta N. So how to have delta N? C plus D minus of A plus B. Number of moles. What is it? Don't remember like this actually. Even I am also wrong. Simply blindly C plus D minus A plus B I am giving. Simply delta N means number of moles of gaseous products minus number of moles of gaseous reactants chemistry. So this is about relation between what? Kp and Kc. And one more I'll give you, that is Qc. Qc is not related to Kp, but Qc is related with Kc. Okay? Qc means reaction quotient. Okay? Not coefficient, quotient. Okay? Qc is for a reaction AA plus BB equilibrium CC plus DD. So for this reaction, important concept. What is a Qc means? Concentration of C power C, concentration of D power D by concentration of A power A and concentration of B power B. And I'll write for the same reaction what is Kc. For the same reaction, what is Kc? Concentration of C power C, concentration of D power D by concentration of A power A and concentration of B power B. So like a mad fellow, same formula written, you're thinking? No, I'm not mad fellow. Here, all concentrations are not at equilibrium. All concentrations means what here? This concentration of C, this concentration of D, concentration of A, concentration of B are not at equilibrium, then we call that as Qc. Okay, so now Kc is what? Kc means here in Kc all concentrations are at equilibrium. This is very, very important. In Kc, all these concentrations are at equilibrium. Here, all concentrations are not at equilibrium. This is the most important thing. Sir, here also can we have any relations? Means yes, case 1, case 2, like that I can give you. In case 1, if I am saying Qc is greater than Kc, sir, how we can come to know Qc is greater than Kc? Pakka this Kc is theoretical they will give actually. This we have to find. They will say concentrations of reactants and products, some X, Y, Z, like that. Then you will find out Qc. They will give Kc. Then you will compare Qc and Kc. You will compare which is big. In comparison, if you came to know that Qc is greater than Kc, I repeat, in question Kc they will give, Qc you will calculate, because at certain instant they will give these concentrations, not at equilibrium. Okay, so Qc you will calculate. You came to know that if Qc is greater than Kc. So really, if Qc is greater than Kc, when Qc can be greater, product concentrations are more. Correct? Correct or not? Numerator should be more, then only Qc can be greater than Kc. If numerator is more, then whose concentrations are more? Product concentrations are more. If product concentrations are more, then what reaction takes place? Then backward reaction takes place. What reaction takes place? Backward reaction. Why? You know this everyone. Rate of backward reaction is equals to Kb into concentration of products. So Qc greater means product concentrations are more. If product concentrations are more, then rate of backward reaction is more. Means backward reaction happened. Rate of backward reaction means what? Products can convert to reactants because backward reaction rate is more. So products can easily convert into reactants. So when it is case 1, if Qc is greater than Kc, then backward reaction takes place. Case 2, if you can understand easily, QC is less than KC. QC is less than KC now. This QC became small, means denominator is big. In denominator, whose concentrations you have? Reactant concentrations you have. So reactants are more, then forward reaction is more, because rate of forward reaction is more now. So if QC is less than KC, then forward reaction takes place. And don't ask me what happens if QC is equal to KC. QC became QC is all equal to KC happens, then what sir means? At equilibrium, that's it. Reaction at equilibrium. So case 3 is a very simple. If QC is equal to KC, then these concentrations are at equilibrium, that's it. So then equilibrium at, then you can say reaction at equilibrium, that's it. So this is about reaction quotient. Okay, so this is not reaction quotient, just simply rate of backward reaction I was given. So QC you have and KC you have there. QC greater than KC, what happened? QC greater than KC means what happened? QC less than KC means what happened? If QC is equal to KC, what happened? I told you. And when you call that QC, when you call that KC, I told you. In QC, all concentrations are not at equilibrium. So important, please have a look. So I was given a relation between Kp and Kc. I was given what, sir? Relation between QC and Kc. So important, sir, please note it down. So next we will go some kind of concepts which are useful to solve numericals. Okay, so I'll give like cases here. So case 1. Okay, if number of moles of N2, like that, not required, you will get confused. If nitrogen N2 react with H2 in a 2-liter vessel, forms NH3. Okay, at certain 27 degrees Celsius, like that. Then what is Kc? Then Kc is, okay, question, if 40% of N2 reacted, 40% of N2 reacted at equilibrium. So when the reaction reached equilibrium, 40% of N2 consumed, 40% of N2 converted as product. So remaining 60% of nitrogen only present once at that particular equilibrium attained. So simply I'll tell you, 40% reaction happened at equilibrium, means at equilibrium 60% of nitrogen present. That's it. So here, when there was not mentioned how many moles of N2, how many moles of H2 reacted, then you have to write a balanced equation. N2 plus 3H2 equilibrium 2NH3. Okay, so initially in numerical, is there mentioned how many moles of N2 present? Is there mentioned how many H2 moles present in 2-liter vessel? Here you have a 2-liter vessel. There was not mentioned how much N2 is present, how much H2 is present in this vessel. Then initially from the reaction only you have to consider how many moles we have to take. Initially from the reaction, if you see 1 mole of N2 reacted, so 3 moles of H2 reacted, and initial means there is no product. Certainly, because initially who will be present in vessel? We are adding only N2 and H2. Are you adding ammonia? No. So initially ammonia is 0. So here at equilibrium, how much N2 is reacting? X. How much H2 is reacting? 3x. As I told you even in limiting reagent in previous class, so the reaction always happened equally. One volume of N2, 3 volumes of H2 will react and 2 volumes of ammonia will give. In that way only we will do numericals. Okay. So here 1 mole, so x moles. 3 moles initially present, so 3x moles will react. Reaction, remember, this x and 3x always depends on the number of moles what we have. Even they given 4 moles here, even here they given 8 moles, not matter how much they react, means only reaction accordingly. Okay, according to the reaction, how many moles of N2 is there? 1, so x moles will react. How many moles of H2 will react? 3x moles. Got it clearly? So here 2x will form because 1 mole and 3 mole, 1 mole from the reaction. Forget about this 1 and 3. 1 mole and 3 mole will give 2 moles. Understanding, sir? So x moles and 3x moles will give 2x moles. So at equilibrium reacted, these are reacted. So at equilibrium remaining moles how many? So remaining is 1 minus x, because x moles reacted, so that x we have to subtract from the initial moles what they given. So they was not mentioned, means we have to take 1 mole. So 1 minus x, the remaining are 3 minus 3x moles. Here initially 0, so 2x moles. 2x moles will be there at equilibrium, because 1 mole and 3 mole is giving 2 moles in the reaction. So x and 3x moles will give 2x moles. So at equilibrium, I told you that 40% of N2 reacted. 40% of N2 reacted means, what is the meaning? So 100% means certainly 1 mole. So 100% means 1 mole. So 40% how much you can take, or 60% how much you can take. 60% will become this 1 minus x. 40% this one, x moles reacted. Correct? 60% will be how much? So you can have 60 by 100. So 0.6. Otherwise x is 40. So x is 0.4. Sorry. In that way also, because 40% reacted, so x will be 0.4. Otherwise 1 minus x will be 60%. Because 40% is reacted. 40% reacted. Don't think 40% is 2x. No. Because x moles is giving 2x mole. And how this 2x is 40%? No. N2 reacted 40%. So this x reacted, no. So 40% is x. So 1 minus x is the 60%. So you can write now, see this 60%. What is the 1 minus x here? 60%, no, that's this one. So 1 minus x is 0.6, then x is 0.4. So this one 3 minus 3 into 0.4. This is 2 into 0.4. X is 0.4. So what is Kc? You can write now. Kc is concentration of NH3 whole square by concentration of N2 and concentration of H2 over 3. This is Kc. So now what concentrations? This 0.4. So sorry. This x is 0.4, but 1 minus x is 0.6. This you have to take. So what is N2 concentration? N2 is concentration means, now this one is 0.6, because N2 concentration remaining is 1 minus x, no. So 0.6 by 2, because concentration always moles by volume. Concentration means moles by volume. So what is the volume here? 2 liters. That's why denominator 2. How many moles remains? 0.6. That's why 0.6. How many moles of H2? Sorry, what is the concentration of H2? This is 3 minus 1.2. Right? If I am not wrong, this is 1.8. Because, correct, huh? 3 minus 1.2, right? So 1.8 by 2. 3 minus 1.2. 3 into 0.4. Correct now? So concentration of NH3, how much? It's number of moles 0.8. 0.8 by 2. 0.8 by 2. So this simplify and substitute here so that you get Kc. In this way, you can have what is Kc. Got it? Because at equilibrium they said. That's why I said Kc only I was taking. Okay? At instant if they said I calculate Qc. That's it. These are the moles. 1 mole, 3 mole. They was not mentioned. So I was consider initial moles from the reaction only. Got it? Okay. Now I'll change question. Case 2. So have a screenshot, please. Now I will give you the most important. What is that? See here. Same but bit different. Here initially 4 moles of N2 and some 8 moles of H2 reacted. So 4 moles of N2, 8 moles of H2 reacted in 2 liter vessel. Okay. 4 moles. How many moles? N2, 4 moles of N2. Okay, how many moles? 4 moles of N2 and 8 moles of H2 reacted in 2 liter vessel. Same 40% only I consider. So that now initial will change. So here how initial I have to take? Initially how much given? 4 moles. Initially how many moles of H2 given? 8 moles. See. To buy a book 100 rupees is required for you suppose. But you father given excess. 500 rupees he given. So will you give 500 rupees in a store and you won't take change back? No, you will give 100 rupees only for that book and you will take 400. So 400 is excess with you. In that way, they react 1 mole and 3 moles here, but they given excess 4 moles and 8 moles remaining. So remaining 1 and 3 if you see, remaining moles with you only. So excess. Got it clearly? So as I said, 1 and 3 moles only will react. But given excess 4 and 8. But remember, at equilibrium, reaction always happens, okay, based on the number of moles what you have in reaction. Even 4 moles, Giri number of moles or any number here given not matter. That they give an excess. But here, how many moles you have, those many only will react. Accordingly, you have it. 1 mole react, so X moles you have to take. Good. Got it clearly? Because 100% is not there, so that's why I am not writing 1 here. So 40% that's what reacted. So I am taking that 40% as X. If I into 40%, so here 3 into 40% will react. That's why 3x moles. So here 2x moles will be formed and remaining moles how many? Remaining moles at equilibrium how many means? 4 minus x, 8 minus 3x, 2x. What I did? Anything wrong I did? Oh my god sir, reaction always happen based on the number of moles what you have in correct balanced equation. Important. But here they given 4 and 8. What I can do? Excess they given. I asked 100 rupees, but my father given 500. So I need 1 mole of N2, but 4 moles of N2 was given. But even you have 4 moles, the reaction will be based on this moles what you have in this reaction. So 1 mole is there, so X moles will react. So don't, few people think, sir 4 moles is there, so 4x. In previous 1 is there X, 3 is there, so 3x. Now 4 is there, so 4x, 8 is there, so 8x. No, that much is not required. Simply 3x only will react and here x only will react. So remaining moles means 4 minus x, 8 minus 3x, 2x because excess is there here. Now same story, but 100% means how much? 100% of N2 means 4 moles I have to take now, because remaining moles means we have some X you are subtracting from 4. So 4 is the 100% now. Sir, in previous 100% means 1 you taken, sir, because there was not mentioned in vessel 4 moles, 3 moles like that, not mentioned. So from the reaction I have how many moles here? 1 mole, that much only I was taken here. Now I have 100%. So 100% of N to 4 moles, so 40% you want, or 40% why? You will get confused, because 4 minus X you have no here directly, that you take, no problem. So otherwise 40% you can take, and you can write here, no problem. So 60% of N2 means how much? 60% of N2, very simple. 60, so this will be like 4 minus X. 4 minus X is this. Understanding? So 4 minus X means now 60 into 4 by 100. So it's 240, okay, 240 by 100. So it's 2.4, right? 2.4. So here I can say now 4 minus X is 2.4. So this is 2.4. Now X is how much? X is 4 minus 2.4. So it's a 1.6. 1.6, no? X. So here 8 minus 3 into 1.6. Yeah, 2 into 1.6. By dividing with volume, you can substitute in this Kc so that you can find Kc. Correct? These are the moles at equilibrium. But you needed concentrations, right? So volume is important. Don't forget volume. Will you forget? No. So volume you have 2.4 by 2, this by 2, this by 2. Like that you have to. So this is what now? Case 2 over. Now we have to discuss about case 3. Okay, sir? Important. What is the case 3? Now, same here you have like this. Now I'll change the question. Okay, same but given like this. I'll change. What I'll do now? Case 3. Same. 4 moles of N2 and 8 moles of H2 and 1 mole of NH3 present in 2-liter vessel. In 2-liter vessel. Same, if 40% of N2 reacted at equilibrium, then Kc. Same reaction why I am giving, just to make you easy so that you can compare in all the reactions what we are doing. Okay, now what I will take? Same story, N2 plus 3H2 equilibrium to NH3. So initially, this is actually balanced equation only, you have to write first. So you have to observe the reaction. Okay, they given 4 moles of N2, 8 moles of H2 and 1 mole of ammonia also there initially. In previous ammonia we taken 0. Now ammonia you have to take 1 mole. Because ammonia already present in that vessel, 2-liter vessel. So here 1 mole you will take. Sorry, I won't take 1 mole because my father given excess amount in that numerical. So 1 mole actually from the reaction required, but 4 moles given. 8 moles, 3 moles required, 8 given. 2 moles have formed, but 1 mole initially given. So I won't take 0 now this time. So at equilibrium, what happened? At equilibrium, how the reaction happened? Reacted. Okay. Reacted is X and 3X is 2X. But X and 3X are reacted, but 2X formed. Difference is there. Reactants will consume, products will form. So here what you have? Remaining moles. So remaining moles what you have? Here 4 minus X, here 8 minus 3X but here 1 plus 2x you have taken. Why you taken 1 plus 2x, sir? Initially 1 mole is there, 2x moles formed. So 1 plus 2x you have, 8 minus 3x, 4 minus x. Same story. 100% of N2 is 4. 60% how much? In this way, we can calculate what Kc. Sometimes Kp also they will ask, partial pressures they will give. Otherwise, if they was not given partial pressures, they will give information like this, and you have to find moles. Then you have to take relation. Kp is equals to Kc into RT power delta n. Okay. So you have to solve only this kind of numericals. Okay, very big chapter, very important. And afterwards, I'll give you only one more concept, that is the Le Chatelier principle, and we will enter into ionic equilibrium. Okay, thank you so much.